Today I'm going to show you the secrets of Argand diagram in complex number so that you'll be able to solve polar form and Euler form of a complex number. Just watch, stay back and see the end of this video. It's going to help you. When we talk about Argand diagram, a diagram that shows the argument and modulus of a complex number, something like this. This is Argand diagram. Okay, this is y, this is x, this is modulus, okay, and this is a complex number. So this is Argand diagram. This place is argument. This is modulus. So when we talk about this, here has I, positive and positive x. So in Argand diagram, we talk about this is complex number. The modulus of this complex number is square root of x squared plus y squared. Now, if we are talking about the argument of a complex number, all we need to do, because this is modulus, argument of a complex number, we call it theta, which is equal to tan inverse of y over x. So when you are in first quadrant, you regard this as the argument. But the moment you move to second quadrant, remember, we have it as 180 minus theta. So for second quadrant, it's 180 minus theta, which is the same as 180 minus tan inverse of y over x. Remember, your question will always come in this form, x plus yi. But there is a complex part of this. How will you identify a complex number that is in first quadrant, that is in second quadrant, that is in third quadrant, and in fourth quadrant? In this video, you are going to see how a complex number resides in first quadrant, how a complex number is in second quadrant, third quadrant, and fourth quadrant. So now, for first quadrant, a complex number looks like x plus yi. This is how it looks like for first quadrant. When you see a complex number like this, know that it is in first quadrant. Then when you see a complex number like this, minus plus yi, minus x plus yi, know that this complex number is in second quadrant. When you see the one in third quadrant, it's going to be negative x, negative yi. Then the one of fourth quadrant is going to be x, negative yi. So this is how you identify the quadrant in each quadrant, the complex number in their respective quadrants. Complex number in first quadrant, complex number in second quadrant, third quadrant, and fourth quadrant. So for the solution, if you are given this and you're asked to find the argument, this becomes your answer for first quadrant. So if your question is like this, x plus yi, okay, then the argument is like this. Theta is equal to tan inverse of y over x. All of these have the same modulus, x squared plus y squared. Take the square root. That is how you do it. Now, if you are given second quadrant question, minus x plus yi, what will you do? This is it. 180 minus theta. You first of all find theta, and theta is tan inverse of y over x. So with this is the quadrant. The second quadrant, the argument of the second quadrant is this. Okay? The argument of the second quadrant. And also, theta plus 180 becomes argument of the third quadrant. Then 360 minus theta becomes fourth quadrant. So these are the different arguments we have for first quadrant, second quadrant, third quadrant, and fourth quadrant. So let's solve this question and you will get the answers correctly. Find the argument of z equal to minus 5 minus 5i. When we are asked to find the argument, solution, we don't need to stress ourselves. Argument simply says, look at it. This is what quadrant? This is minus 5i, minus x minus yi. Oh, this is third quadrant. And because it's third quadrant, we have to say the argument in third quadrant is theta plus 180. Okay, now what is theta? Theta is tan inverse of y over x. So we get theta first, tan inverse of y over x. And this is y and this is what? X. So 5 over 5. Ignore the sign here. Let it be the positive value you are picking. 5 over 5, positive value. This cancel this, you have 1. So theta is equal to tan inverse of 1. And tan inverse of 1 is 45. Okay? And if tan inverse of 1 is 45, all we need to do is, you go back again to this place. Theta plus 180 is third quadrant. Third quadrant is minus x minus yi. So we now use theta plus 180. And theta is now 45. So 45 plus 180. Okay? We have 225 degrees. So axis, therefore, is equal to 225 degrees. So that becomes the answer to this question. Adibin, you are asked to find the modulus of z equal to 3 minus 4i. First of all, whether it is in first quadrant, second quadrant, third quadrant, fourth quadrant, it doesn't concern us because it is called what? Modulus. Where you take importance in this is when you are asked to find the argument. So for modulus, it's just like radius. Okay? So modulus is square root of 3 squared plus 4 squared. Pick the positive value. Don't ever touch the negative value. So you come over here and say modulus is equal to square root of 9 plus 16. 9 plus 16 is 25. So modulus is equal to square root of 25 is equal to 5. So that is the modulus, irrespective of the quadrant. But however, 3 minus 4i is in which quadrant? Fourth quadrant. So it is in fourth quadrant. If you are asked to find the argument, just simply come over here and say 360 minus theta. And theta is what? You find theta and subtract it from 360. That will be the argument of this question. But we are not asked to find the argument of the question. Okay, let's see. When you are asked to express a complex number in polar form, this is a complex number. Express this, x plus yi, in polar form. What will you do? Polar form, first of all, is r is z modulus. This is modulus, is same thing as r. Okay, remember that r is equal to z modulus. So r into cos theta plus I sine theta. So now this is a simple expression of polar form. And now we have another expression, we call it Euler form. Euler form. Another expression for Euler form is Z is equal to R E, you can call it J or theta, J theta, either I J theta or J theta, okay? But this is the expression for Euler form. Z is equal to R E raised to power J theta. Now, in a question where you are asked to express, there is a question where you are asked to express Z equal to minus 3i in polar form and Euler form. What will you do? Okay, express Z is equal to minus 3i in polar form and Euler form. So all we need to do is solution. What is the Argand diagram? What is modulus? So modulus is R, which is the positive coefficient of Ri, which is 3. So if modulus is 3, arg Z is equal to what? Now this is minus 3i. Let us look at this. Very important. Here is yi positive, and here is minus yi. From here to here is 90 degrees. This is a secret I'm giving to you. From here to here is 90 degrees. From here to here is 90 degrees, which is 180 degrees. And from here to here is another 90 degrees, which is 90 plus 90 plus 90, 270. So from here to here is 270. If from here to here is 270, why are we stopping at this place? Because minus yi looks exactly as minus 3i. Okay, so this is where we stop as for the argument. So the axis is sum everything here. Okay, so 90 plus 90 plus 90 will give us 270. So the axis of anything that looks like this on y-axis will give us the value 270. So this is 270 degree. So do not be surprised when it is plus 3i. You know it is 90 because from here to here is 90. Maybe you have plus 3i. Okay, z is plus 3i. The answer is from here to here is 90. But it is not plus 3i, it's minus 3i. The answer is 270 degrees. Now, because we've known the axis and r, remember the expression of polar form. Polar form is equal to r, which is 3 into cos theta is what? Axis, which is 270, okay, plus I sine 270. So that is the answer to polar form. Then, Euler form, okay, Euler form is equal to, what is R? 3 E J 270. So that is it for this video. I hope you enjoyed the video. If you do, like, share, okay, and subscribe to my channel for more videos. Bye.